Hi, I'm Pierce Jentz with Baratza Support. Today we're going to walk through replacing the motor on our conical grinders, including the Encore and the Virtuoso. I have an Encore with me here that does have a bad motor in it, and as you can see, it's running, but if you try enough times, it doesn't run. Let's go ahead and take this grinder apart, check the motor to make sure it is indeed the bad part, and put in a new one. Let's get to it. We'll start by unscrewing the hopper counterclockwise until it stops, and then you can go ahead and lift it off to remove it. There's a black gasket that lifts out to remove, and then we can lift out the burr by the red and the white tabs to remove that. The knob you simply grasp and pull firmly off the side of the grinder. It's a press fit. And from here, actually, let me go ahead and remove my grounds bin, and I'm going to put my gasket, knob, and upper burr in here so I can keep track of them. And at this point, we're ready to take the case off the grinder. Removing the case requires the use of a flathead screwdriver. We actually have an entire walkthrough that details the step-by-step process of removing the case, and I recommend that you check it out if you've never taken one of these off before. After removing the case, the next step is going to be to lift this safety interlock switch up and off the two posts that it rests on. After you pull it off, you can go ahead and let it dangle to the rear. We'll leave it there while we conduct the rest of the repair. With the safety switch out of the way, we're ready to remove the 3 screws that secure the motor and gearbox housing to the black chassis. On my grinder, these are T10 screws. These could be Phillips screws as well. Over the years, we've used 2 different screw heads for the screws that hold the gearbox down and hold the motor plate to the gearbox. We have a Phillips screw and we have a T10. Depending on your grinder, you may have either of these screws under the hood. Now, we also are going to take the motor plate off of the motor so we can install our new motor. And we've used 3 different screws for that connection in the past. We've used a Phillips head screw, a 3mm hex, and a 4mm hex. So in general, if you have a Phillips hex key set, which would have both a 3 and a 4mm in it, I would hope, and a Torx 10mm driver, then you'll be prepared for whatever screws may be under the hood. On my grinder, the rear screw and the screw on the side above the knob are actually a bolt with a nut on the bottom. You'll notice when I'm loosening this screw, I'm going to hold my finger down below so that this small nut doesn't escape me. I'm going to go one step further and remove my lid from my hopper and use that as a parts tray. The rear bolt and nut also go through a rubber grommet that's removable. This thing can fall off while you're doing your repair and escape unnoticed. So I'm going to go ahead and pull it out of position and put it in my lid now. From here, we'll do the nut and bolt that sit over the top of the switch. I'm going to use the same technique by loosening the bolt and putting my finger underneath the nut to catch it. The 3rd screw is a self-tapping screw and does not have a nut. On my grinder, the screw came out along with the insert for the motor mount grommet. I'm going to go ahead and hold the motor mount grommet insert, this white piece, and take the screw out of it. I'll put the screw in my parts tray, and I'm going to put this white insert back into the rubber bushing for safekeeping. At this point, I can remove the gearbox and motor assembly entirely. However, I want you to take care to keep track of your chute gasket, this rectangular black gasket. It may be on your chute, it may be on the chassis. Find it, grab it, put it in your parts tray. Unplug the motor from the circuit board. On older machines, you may need to unplug the wires from the bottom of the motor. Now that we've separated the chassis and the gearbox motor assembly, I'm going to go ahead and set my chassis off to the side to clear my workspace and concentrate on changing the motor. There are 4 screws that hold the motor and motor plate to the white gearbox housing. The black piece is the motor plate, the silver cylinder is the motor, this white piece is the gearbox housing. I'm going to go ahead and remove these 4 screws. On my grinder, these are again T10 Torx 10 screws. They may be a Phillips on yours. The motor has large magnets in it, and the screws are magnetic, so they'll stick to it. Make sure you keep track of all your screws. I have my 4 screws from the motor plate that I'll put in my lid, and at this point I'm able to separate the motor and motor plate from the gearbox housing. I'll put the gearbox housing to the side because we're changing the motor. There are 2 screws that secure the motor to the motor plate. On my grinder, these are 3mm hex. So I have my 3mm hex bit. I'm going to go ahead and break these screws loose. These are the tightest screws of all that we've taken out so far. That's why you'll notice I have a different tool to loosen them. And once I have loosened them just a little bit, I'm going to go ahead and use my power tool to take them the rest of the way out. I recommend leaving the motor screws in the motor plate, but so you can see what we're dealing with, there's a lock washer for each of the screws that secures the motor to the motor plate. You want to use the 2 holes that are in alignment with the bushing and the motor hole for your 2 screws. That is, you want to put the screws in this hole and this hole. You don't need to use these 2 holes. So I'm going to go ahead and grab my new motor, but actually, before I grab my new motor, I'm going to test the old motor and make sure that it's a faulty part. There's at least two ways you can test the motor. I want to show you first how to use a multimeter to test your motor. I have a fluke multimeter here. Multi meaning it has multiple functions. What you really need is the ohm meter function of the meter. That's this omega horseshoe shape. Ohms is a measurement of electrical resistance. If I take my 2 probes and contact them with each other, we have a reading very close to 0 ohms, which means there's almost a perfect electrical connection. That tells me that my meter is working. I want to test the resistance of my motor because electricity needs to be able to pass through the motor for it to do any work. So what I'm going to do is insert my 2 probes into this motor connector. And if your probes are making a good connection with the wires through this connector, then you should get an electrical reading. On the fluke meter, 0L, which is what's currently being displayed on the screen, and let me turn on the light for you. 0L means that there is no electrical connection. If I rotate my motor, we can check for flat spots. Now, after 2 small rotations of the motor, I have a reading of 31.7 ohms. Don't fret about the exact value of the reading that you're getting. What I want you to look for is whether you're able to get a reading or not. Getting a reading is good. Not getting a reading is bad. That is a flat spot on the motor. There are 12 poles on the motor, so you want to rotate the motor around in 1/12 increments to check all the poles. 0L, 0L, something in the 30s, something in the 30s, 0L, 0L, something in the 30s, something in the 30s, 0L, 0L, 0L. This motor has a lot of flat spots on it. Now let me contrast that to a new motor quickly. I'm going to conduct the same test with my new motor. "17, yes, it's different than the 30 reading we're getting on the other motor. Again, I want you to concentrate on the fact that we're getting a reading, not what the value is. 17, 17, 17, 17, 17. You'll see my meter is flashing OL just for a moment, and that is when the motor is being rotated. Whenever the motor is still, it's able to get a reading. There are no flat spots on my new motor, as you'd expect. Now, ohm meter or multimeter is not a tool everyone has at home, so let me show you a different technique to check if your motor is indeed the faulty part. You can use a battery and a paper clip to check your motor. What I have here is a 9-volt battery, common in the US, and a standard paper clip. What I'm going to do is straighten the paper clip out, and you'll see why in just a moment. First, let me show you how the motor should operate. This is my new motor. I'm going to go ahead and unplug one of the 2 wires from the bottom of the motor. It doesn't matter which one. Next, I'm going to take my straightened paper clip and I'm going to push it into the motor connector on the side of the wire that is still attached to the motor. I have my black wire attached to the motor. I'm going to insert my paper clip into the side of the connector that goes to the black wire. Next, I'm going to take my battery and I'm going to connect one of my 2 battery ends to my exposed lug. Finally, I'll take my paper clip and I'll complete the circuit. So what I'm doing here is I'm running electricity from one side of the battery through my paper clip, through my black wire, through my motor, out the other side of the motor to the other side of the battery. I'm making an electrical circuit. And the motor runs. You'll notice that the motor is not running very fast. That's because it's running on a low voltage. In the grinder, it receives much more voltage than it does from a 9-volt battery. But it tells me that the motor does indeed run. I can break the connection, and every time I make the electrical connection, the motor runs. Now let's take a look at the bad motor using the battery test. I'm going to set it up in the same way, in that one wire needs to be unplugged from the bottom of the motor. We're going to put the paper clip into the motor connector that has the wire still attached to the motor, in this case the red one. We'll put one part of my 9-volt battery on my exposed motor lug, and we'll finish the connection by putting my paper clip on the other one. Oop, the motor ran just for a second there. Let me try that again since it slipped. I'm getting no action from the motor, so what I'm going to do is I'm going to try rotating the motor to a different pole, and we'll try again. Oh, a little bit there. So unlike the good motor, this motor is not able to run continuously on my 9-volt battery. This is confirming that this motor is indeed bad. Let me show you again the short burst of running that it is sometimes able to do. You can see this motor has several flat spots. I'm having difficulty. There was a good spot. Let's see what else we can find. But it's not able to run continuously. This is a looser way to check the motor, but it still gets her done. Now that we know our motor's bad, let's install our good motor. I'll go ahead and put the bad motor way off to the side so I don't have any accidental mix-ups. Put my 9-volt battery to the side as well. I won't be needing that any longer. For the new motor, I unplugged the wire from the bottom of it. And I want you to notice that the red wire goes into a connector on the bottom of the motor that's marked with red. If you were to accidentally switch these and have the black wire plugged into the lug that's red, the motor is going to run backwards, and that will not let your grinder grab the beans and pull them into the burrs. In fact, it may result in your burr unscrewing itself when you try to run the grinder. So take care to plug these wires in properly, matching the red with the red. In fact, when you take delivery of your motor, it's likely these wires are already going to be attached right from our shipping depot. Alright, I'm going to grab my motor plate. It has the motor mounting screws and lock washers in place. And I'm going to go ahead and set it on my motor. If you have the wire pointing off at a slight angle, it makes for better wire routing in the grinder, but you can put it in any which direction and the grinder will still assemble happily. However, I am a fan of tidy wire routing, so I'm going to have my wire bundle point off to the side away from the edge of the motor plate that has a cleft in it. And at this point I'm going to go ahead and tighten my two 3mm hex screws that secure the motor plate to the motor. My electric screwdriver is not very powerful, and these are two screws that you want to have rather tight. I'm going to change from my electric screwdriver to a ratchet to do a final torque pass on these two screws. They're small screws, they don't need to be very tight. You can see I do not strain, but I am able to get the screws 1/2 to 3/4 of a turn tighter than my electric screwdriver was capable of. Next, I'm going to put my motor and motor plate onto my gearbox. The drive shaft goes into a bushing on the motor plate. And a little bit of a wiggle helps the parts slide together nicely. Next, I'm going to put the 4 screws that hold the motor plate to the gearbox in position, and after I have all 4 ready, I'm going to tighten them. A good general rule of mechanics is to have all your bolts started before you tighten any of them. It generally makes life a little bit easier because sometimes tightening a bolt can make your next bolt harder to get started. These 4 screws do not need to be very tight. My electric screwdriver has more than enough power to get these 4 screws tight enough. Now that I have my motor and motor plate reattached to my gearbox, I'm going to go ahead and put this assembly back into the chassis. First, I'm going to grab my rubber chute gasket. Looking at the gasket, 3 of the sides are similar and one side is different. It has a bit of a wrinkle or a mottle in it. And that is there to make it fit best with the slot in the chute where the chute rides against the gearbox housing. I'm going to make sure my chute gasket stays in place while I go ahead and get the assembly into position. the interlock switch should still dangle freely in the back. And at this point, I'm going to take the opportunity to route my interlock switch wire inside of the bolt that goes above the switch. This is going to make the case removal easier when we get the repair finished up. This is going to make the case installation easier when we get the repair finished up. In fact, I'm going to go ahead and sit my safety switch back in its proper position. I can go ahead and push it onto these two posts. And don't forget, plug your new motor into the circuit board. From here, we're ready to put some screws back in. I'm going to grab the rear motor mount bushing. I'm going to grab the rear motor mount bushing and put it in position in the horseshoe shape on the back of the gearbox. Next, I'll go ahead and get one of the bolts, put it through the bushing, through the hole in the chassis. I'm going to go ahead and get my other bolt with nut and put it in position above the switch on the side of the grinder. The chassis of the grinder is designed such that it holds the nut from free spinning. That means that as a repairman, you only have to rotate the bolt. You don't have to also hold the nut. What I like to do with my electric screwdriver is rotate the bolt in the tightening position and simply press the nut up against the bottom of it. The 3 screws that we're currently installing do not need to be very tight. In fact, you want to be very careful not to make them too tight, as you can break your chassis. With my electric screwdriver, I have a technique that allows me to make sure that it doesn't get very tight. And that technique is simply that I don't hold the screwdriver very tightly. That way, when the screw gets tight, the screwdriver is able to slip freely in my hand like this. If you're using hand tools, take great care to not over tighten these 3 screws. In fact, as soon as you feel the screw starting to become tight, you're good to go. The 3rd screw, the one that goes above the bin area, is the different one that does not have a nut. Older grinders do not have a nut. Instead, they have 3 of the screw that is self-tapping. Now that I checked my hopper lid, I have no leftover parts, which is good. That means I'm ready for my final assembly. At this point, I'm going to snap my case back into position. And I'm actually going to test the motor before I put all my parts back in. To test the motor, you do need to install your whole bean hopper and rotate it to a grind setting less than 40. This is required because there is a safety interlock switch inside the grinder, that one we were lifting off the 2 posts and putting back in position. Installing the hopper and rotating it clockwise engages that switch. Unless that switch is engaged, your motor will not power on. I'm going to go ahead and plug the grinder back into a good outlet and give it a test. The grinder starts every time that I ask it to, as it should. My motor repair is a success. At this point, I'll go ahead and remove my hopper, install my ring burr with the red dot near the front right. It will line up with the grind setting of 30 on the case. The gasket has 2 notches that sit on top of the red and the white tab, and it simply presses into position. Reinstall my hopper, my lid, my knob, my bin, and the Encore is ready to go back into grinding action.